Hi and welcome back to Module 7 and Inquiry Question 7. What are the properties and uses of polymers? So just a reminder of what we're looking at today. We're looking at modelling and comparing the structure, properties and uses. They're the three terms of addition polymers, and today we are focusing on polyvinyl chloride as our example of a polymer being made from the monomer of ethylene. So today we're looking at polyvinyl chloride, PVC. So again, as the name suggests, poly meaning many, vinyl chlorides. So we've got chlorides there in our chloroethene. So we're still using ethene, I suppose, as our base monomer, but in this case here we now have a chlorine in that monomer as well. So the only difference really between the PVC monomer and our previously polyethylene monomer is that presence of chlorine. So when we produce our polymer, you can again see the structure is basically the same for our polymer. We have got that structure here with the N on the end is how we represent that, and again the difference is that chlorine. So we're going to see that alternating chlorine in our polymer if it's completed. So every second carbon then is going to have a chlorine on it, but in the same way that we had with polyethylene, we are getting that breaking of that double bond, the opening up of that double bond, which is creating two extra bonds for those other chloroethenes to attach to repeatedly to produce our polymer there. Now, many of you will have heard of PVC before. PVC piping is a common use. They're quite strong. They've got to, again, be fairly chemically inert for the purpose of carrying water and so forth. So let's have a look at some of those properties that we have. Think of our polystyrene pipe that we use regularly. It's hard. It's rigid, it's lightweight, reasonably light for maybe its size. It's a good insulator that we have. A great thing is it's insoluble in water in that it is used in plumbing. It's quite durable, again acid resistant, flame resistant, but in this case now it has a higher melting point. So another use is also in electrical insulation, which is due to the property of being a good insulator. So here what happens, the chlorine is introducing dipoles. We now got carbon chlorine bonds there. Again, the difference in the electronegativity that's not so present between the carbon and the hydrogen. So we're getting polar bonds. By having polar bonds as opposed to just the dispersion bonds, this is increasing the melting point. So everything we're doing is still linking back to everything that we've done previously. So it's got few polar bonds, not as many as if every carbon had a chlorine on it, but fewer polar bonds are leading to that being insoluble in water. Now, the carbon-chlorine bond can be attacked by UV light. So obviously leaving some of these PVC products out in the sun can make it susceptible to breaking down, as we see some of those things becoming brittle over periods and periods of time. What we'll do is we'll have a look through some of those questions that we've got in our booklet, and we'll talk about this a little bit in more depth later. Only a short one today. See you later.